doesn't care about the noise. It only cares about five specific skills. After analyzing thousands of job postings and talking to hiring managers, we've identified the five core AI skills that will actually get you hired. Master these, and you will be ahead of 90% of the applicants flooding the market. In the next few minutes, you will learn the exact five skills recruiters are desperately searching for, why most engineers are climbing the wrong ladder, and the one strategic mindset that can more than double your salary. We'll cover the architectural thinking that separates a $100,000 engineer from a $300,000 architect. We'll look at the critical eye for data that every single AI model depends on. And I'll show you why knowing when not to use a complex tool is the most profitable skill of all. Let's start with the first and most overlooked skill, translating a business problem into an AI system design. Most engineers hear a problem and immediately jump into coding a solution. This is a fatal mistake. The highest paid AI professionals spend most of their time on a diagram before writing a single line of code. They decide upfront, is this a job for a RAG system, a fine-tuning project, or a simple classification task? Choosing the wrong path is the number one reason AI projects fail, and it's why this strategic skill is in such high demand. It's not about coding faster, it's about thinking better. Second, data proficiency. But this is not what you think. It's not about complex data science or building ETL pipelines from scratch. The most valuable AI engineers are simply ruthless about data quality. Imagine trying to teach an AI to recognize dogs by only showing it pictures of golden retrievers. The AI will become a world expert on golden retrievers and be completely useless for identifying any other dog. That is the core problem in a nutshell. Your job isn't to be a data scientist, it's to be a data critic. You must be the person who can look at a data set and immediately spot the bias, the gaps, and the noise, because an AI model is just a mirror. Garbage in, garbage out. This skill is about ensuring you only feed it excellence, so it reflects back intelligence. Third, practical tool selection. While the internet is debating Gemini 3 Pro versus GPT-5, elite engineers are asking a much smarter question. Do we even need a large model for this? This is a massive mental shift. The hype is around building complex AI agents, but the profit is almost always in using the simplest tool for the job. Why use a billion parameter model to classify customer support tickets as urgent or not urgent when a much smaller, faster, cheaper model can do it with 99% accuracy? The real skill is cost-benefit analysis. It's knowing that sometimes the most advanced solution is a simple logistic regression model, not a complex neural network. This mindset saves companies millions and makes you absolutely indispensable. So we have system design, data criticism, and practical tool selection. These first three skills alone will put you in the top tier of applicants. If you're already seeing how this approach is different from just learning to code, do me a favor and hit the like button. It tells the algorithm this is a message engineers need to hear. Now, learning these skills in isolation isn't enough. The fourth and fifth skills are what connect them all, transforming you from a competent engineer into a true AI architect. And the fifth skill is the one almost nobody is talking about, yet it's the single biggest predictor of a seven-figure career trajectory. Let's break that down right now. Alright, let's dive into the fourth skill, the one that ties everything together, integrated system architecture. This is the skill that separates the AI mechanic from the AI architect. The mechanic knows how to build a single component, like a RAG system. The architect knows how to design the entire factory. It's the difference between knowing a single recipe and being a master chef who can design a new menu from scratch. Imagine a company wants to reduce customer support tickets. The junior engineer hears this and immediately suggests, let's build a chatbot with GPT-5. The AI architect, however, stops and asks a completely different set of questions. What kind of questions are we getting? Are they simple factual lookups, like where is my order? Or are they complex troubleshooting questions that require a dialogue? The architect visualizes the entire system first. Picture a flowchart. On the far left, a box labeled Incoming Customer Query. The first thing that query hits is not a giant, expensive language model. It's a simple, fast, and cheap classification model. Its only job is to sort the query into one of three buckets: factual, troubleshooting, or complex. This is the triage nurse of the entire system. If a query is flagged as factual, it gets routed to a highly optimized RAG system. Think of this as the librarian. It pulls the exact shipping information from a database and provides a direct, accurate answer. It's incredibly fast and costs fractions of a cent per query. We are not using a sledgehammer to crack a nut. But what if the query is troubleshooting? This is where the initial RAG only idea would have completely failed. So, the architect routes this query to a fine tuned model, perhaps a specialized version of Claude that has been trained specifically on the company's technical manuals and past support conversations. This model can guide a user through a multi step process. It's the seasoned expert on the team. Only the truly complex queries, the ones that require genuine human nuance, get passed to a top tier model like Gemini with an immediate alert for a human agent to review. This multi-layered design is the essence of integrated architecture. It's not about using the most powerful tool, it's about using the right tool at the right time. One company implemented this exact hybrid approach and saw a 62% reduction in human-handled tickets, saving them an estimated $42,750 in the first month alone. Now here's the pattern interrupt most people miss. The goal of AI is not to build one perfect, all-knowing model. That is a myth. The goal is to build a resilient, efficient system of smaller, specialized components that work together flawlessly. Your value isn't in knowing how to fine-tune a model. It's in knowing when a fine-tuned model is only one small piece of a much larger, more profitable puzzle. This architectural thinking is what justifies a salary over $250,000 because you're not just solving a problem, you're building a business asset. This brings us to the fifth and final skill, the one that almost no one teaches, but every single company hiring for senior roles demands: production-level AI deployment and monitoring. This is the uncomfortable truth of the AI industry. Building a prototype in a notebook is easy. Making it work reliably for millions of users 24/7 is where 99% of projects fail. Think of it this way: building a model is like building a Formula One engine. It's powerful and impressive on a test bench, but production is the rest of the car. It's the chassis, the aerodynamics, the cooling system, the pit crew. Without the rest of the car, the engine is just a very expensive paperweight. Your job is to be the chief engineer for the entire car. This means understanding MLOps. It's not just about writing the code, it's about automating the entire life cycle. Imagine a system that automatically tests, validates, and deploys a new version of your model with zero downtime. It's about building a robust pipeline, not just a one-off script. But deployment is only half the battle. The real challenge is monitoring. An AI model in the wild is not a static piece of code. It's a living system that can degrade over time. We call this model drift. The world changes, customer behavior changes, and suddenly, the model that was 95% accurate is now only 80% accurate. If you're finding this breakdown of real-world AI challenges useful, consider subscribing to the channel. We go deep into these practical, career-defining topics every single week. A leading e-commerce company faced this exact problem. Their recommendation engine, built on user behavior from the holiday season, started performing poorly in the spring. A production-focused engineer didn't just retrain the model, they built a monitoring dashboard, picture a graph tracking the model's key performance indicators in real time. They set up automated alerts that would trigger when the model's predictions started to diverge from actual user purchases. When the system detected a drift of more than 5%, it automatically kicked off a retraining pipeline using the latest sales data. It then deployed the new model into a shadow mode, running it alongside the old one to ensure it performed better before pushing it live to all users. This monitoring and retraining loop prevented a potential 15% drop in conversion rates, which the company calculated was worth over $1.8 million in revenue per quarter. This is the hidden skill set. While everyone else is chasing the latest model architecture from a research paper, the highest paid engineers are mastering the boring stuff: cloud deployment on AWS or Google Cloud, containerization with Docker, and building automated feedback loops. They know that a model that isn't in production is just a hobby. A model that's in production but isn't monitored is a liability. Your ability to turn a promising model into a reliable, monitored, and profitable business service is the final and most valuable piece of the puzzle. It's the skill that ensures you're not just part of the AI hype, but a leader in its practical application. Now you know the 5 core skills. But here's the uncomfortable truth: just knowing the skills isn't enough. The engineers who get the top tier jobs and command the highest salaries also know what not to do. They avoid the common traps that sink most AI projects and careers. The first and most common mistake is the solution in search of a problem. An engineer gets excited about a new technology, like multimodal agents, and tries to force it onto every business problem they see. This is fundamentally backwards. The pro tip is simple: never start with the tool, start with the business metric. What is the one number you are trying to move? Higher customer satisfaction, lower operational cost, faster response times? Define that first, then work backward to the simplest possible solution. The second trap is the perfect prototype fallacy. Spending 3 months in a notebook to push a model's accuracy from 95% to 97%. It feels like progress, but it's a career killer. Consider a real project at a major firm. A brilliant team spent 6 months and over $100,000 in compute costs fine tuning a custom language model for legal document analysis. They achieved state of the art results. But in those same 6 months, a major foundation model released an update with a massive context window that performed the task 98% as well through a simple API call that cost dollars per day. The entire 6 month project was obsolete before it ever launched. The lesson: speed to value beats technical perfection. An 85% accurate model that's in production and solving a real problem is infinitely more valuable than a 99% model that's still on a hard drive. The proof is all over the industry. We see testimonials constantly. A lead engineer from a fintech company recently posted, "The moment I stopped chasing research papers and started deploying good enough systems, my career took off. I delivered 3 projects in 1 year while other teams were still perfecting their first model." Or look at this hiring manager's public post: "Show me a portfolio with one deployed, monitored AI system that solved a real problem. I'll hire that person over someone with 10 perfect GitHub repos of models that never saw the light of day." So, the pro tips for scaling your career are really about scaling your impact. First, always be the person who asks, "Can we do this with a simpler, non AI solution?" It shows you care about results, not just technology. Second, think in systems, not models. From day one, ask how you will monitor it, how you'll get feedback, and how you'll retrain it. Build the factory, not just the engine. This is the mindset that separates the implementers from the true architects. At the beginning, I said mastering these 5 core skills puts you ahead of 90% of applicants. Now you have the complete roadmap. Your next step is not to try and learn all 5 skills at once. It's to pick one. Take the integrated architecture mindset we discussed and apply it to a problem you already understand, maybe from your current job. Don't write a single line of code. Just draw the flowchart on a whiteboard. Visualize the system. This single act of strategic thinking, of moving from code to architecture, is the beginning of the entire shift. It's the step most engineers will never take, and it's why it gives you such an incredible, durable advantage in the market. If you are ready to move from simply implementing tasks to architecting real business value, and you want to see more breakdowns of how to build these systems, make sure you are subscribed to the channel. We break down the career path one system at a time.